Hey guys, it's Mr. Ing. Let's go over Integrated Math 3's quiz number 6. Question number 1, classify each of the following according to the degree leading coefficient that it models. So just so we're on the same page, a degree is the number above here. And let's say I put this here. A leading coefficient is what's in front, okay? And then we have to match it with all of these. So we talked about how LC is leading coefficient, okay? I first want to knock out that the easiest odd is x to the first, and that graph looks like a linear. And then the easiest even that we know is x to the second, which is a quadratic, right? That number 2 is even. So you'll notice that the arrows start up and then end up, okay? So I'm going to keep referring to the easiest ones that we know. And you guys are supposed to drag and drop, but I'm just going to go ahead and draw out a picture, because that gives me, and then I can match it up with my picture and then see if we can drag it over or just write the letter. So for the first 3 here, these in red, these are called end behaviors. It tells us a sentence. And in this sentence, this is the x-axis, and this is positive infinity, and this is negative infinity. Okay, so let me try to draw these for you. As x goes towards the right, the graph goes down. So there's my green arrow, okay? As x goes towards negative infinity or the left, the graph also goes down. Okay, so my graph is going to look something like this. That's all we know, right? So I'll just use a, so what can I know about this one? Well, they're both pointing in the same direction down, so that's an even. So I'm going to write that. This is a even, and the leading coefficient, that the green here, if it is a positive, remember, positive people smile, but a negative person frowns or has a sad face. See that? So ours is negative. So if I look at here, which one of these for A is even and the coefficient is negative, that would be the one we just did. Okay? It's the same thing with B now. As x approaches positive infinity, so that's going towards the right, the graph also goes, f of x goes to positive infinity. And then if x approaches negative infinity, so if you go to the left, the graph's going to go down. Well, which graph has that? That is so this would be an odd degree, and then the leading coefficient would be positive. Why is it positive? Because it stays like the original. Starts down, as I go left, right, starts down, ends up. And this one stays the same, so that would be positive. So it doesn't flip, in no way, it doesn't flip the arrows. So I need an odd degree with a positive leading coefficient. That would be this one right there. Okay, let's do the next one. As x goes towards the right, the f of x, so if I haven't clarified, the f of x, this part is the y-axis. Okay, so in this problem, it's saying that you're going negative infinity. So if you want to, you can write these there on all of them. Okay, so in green, this is saying that the graph goes this way. And then over here, as x approaches negative infinity, f of x goes towards, so as I go towards the left, it's going up like this, okay? So let's just draw a graph. We don't know what it is. All we can tell is just end behavior. And so the arrows are in opposite directions, so that would be a odd, right? And our leading coefficient, okay, now pay attention, it's not the same direction as this one. This would be a positive odd right there, the easy one. So what I'm going to do here is this one's going to be a a negative. Why is it negative? Because these arrows are switched. So let's look for an odd and negative. That would be choice here. Okay, D, E, and F now are, just write this out. Here in green, these are called higher degree polynomials. Higher degree polynomials. Okay, what does that mean? Let's just do D here. Okay, here's my degree. This is an even degree. And the leading coefficient here, there's no symbol of negative, so it's going to be a positive. So this is going to look something like, now, to make this super accurate, because it's the fourth degree, that means it's going to have 4 roots. And hopefully you learned last week, these are the, this is the idea of the fundamental theorem of algebra. This represents 2 reals, and this also represents 2 reals, so 2 plus 2 gives us the 4. But the big idea for this problem is that if you just figure out that a leading coefficient is positive and even, then we're going to put D right there. Okay, let's do E. This here is a odd. You're looking for the highest one, and in order, and this would be a negative leading coefficient. So which one? So if you had to draw a graph, remember the graph is just a visual. So the easiest one would have been like this, right? But because of the negative, they switch sides now. So we don't need this one and this one. Those are gone. So your graph's probably going to look something like 7 of these. 1, 2, 3, 4, 5, 6, 7. That would actually be pretty accurate. And we missed that. Would have gone through -8. Okay, big idea though is that this one is negative and odd. Negative and odd, so that would be here. All right, let's go through this one. Even degree, negative leading coefficient, so evens are normally like this, but because it is negative, it's going to go down. And we can erase these. And then if you want to draw a graph, 1, 2, 3, 4, 5, 6, 7, 8. That's what my graph would look like. So F would be, again, negative and even. That would be up here, F. Okay, let's go through now these over here. I see these are in the same direction, so this is an even degree. And all the arrows should be up like the easiest one. That means the leading coefficient is negative. So G is a negative even. So that graph would go here. Okay, this one, they're in opposite directions, so that would be an odd degree polynomial. And the leading coefficient matches the easiest one when it starts down, ends up, so that would be a positive odd. Positive odd for H would be here. And the last one, these are in the same direction, so that's an even degree. And they start up, end up, which is like the easiest even. So that means I have a leading coefficient that is positive. So I would go here. Okay, so that's the first one. Let's go on to question number 2. All right, let's go over question number 2. Graph the basic function of h of x equals x cubed. So we have, this is the parent function. And we don't have one actually, so let's just draw one really quickly. And you already have those points right here. Okay, so let me draw a couple of tick marks really quickly. So I have 0, 0, 1, 1, and 2, 8. 4, 5, 6, 7, 8. Let's say the graph goes up something like this, okay? And so the big idea is that it's graphing by symmetry. Symmetry, what does that mean, symmetry? So notice how this point goes this way. All right, so we need to draw symmetrical points. And what you're going to do here is if you go right 1, up 1, then in blue you're doing symmetrical left 1, down 1. So that would be a symmetrical point here. And then over here, if you're going right 2, 1, 2, and then up 8, this one you're going to go left 2, down 8. And your point would be here, okay? And so the graph, the parent graph, would go through these points. So this is the parent graph in green here, h of x, which is basically an odd degree polynomial, okay? Now, it tells us the child function this is the child function, or that's what I call it, is negative h of x plus 1. Use reference and symmetry to complete the table. Okay, here's a couple of things that we should notice, okay? The first thing I'm going to do is, I'm going to do this by letters, okay? So, on my formula sheet, we wrote down that if you do something like this, g of x equals a, we can keep the h of x, b x minus c plus d. Okay, and we're going to first notice anything that is different, okay? So I notice the a value here, so that is going to be an a that equals negative 1. That is outside of the parentheses to the left. Okay. Now, here, there's nothing to the x to inside the parentheses to the left. So let me highlight this parentheses here. Now I'm talking about the terminology inside. So there's no b value. You can write that if you want or note it. Okay, to the right, let's change colors here. To the right of, did I change colors? To the right of the x value would be a c value, but there is none. So it doesn't say plus 0 or minus 0. So c is equal to 0. And then the last observation we have is to the right of the parentheses in red is our d value. Our d value is 1. Okay, using my formula sheet, I can now interpret what the a value does. So if the a value is less than 0, then this is going to show a reflect over the x-axis. Okay, this is what the a value is doing. And then the d value of positive 1, if it's greater than, this is called a vertical shift up. Vertical shift up 1 unit. Okay, so that's getting my letters. Okay, now what's the equation or formula that we've been using? And I called it the rule on your formula sheet is 1 over b x plus c, comma ay plus d. Okay, so let's go ahead and just, if you notice, I don't need a b and c value. So what I'm going to do is I'm just going to erase this from our formula because we don't need it. Okay. Now let's just substitute the information we have here. We said a value is -1. So I'm going to put a -1 here. My d value is 1 here. So that would be a +1. Okay, and everything else is the same. So we have just an x. Guess you don't need that plus sign here. And -y plus 1. That's the formula. Okay, so what this means, let's see if, okay, so that means the x value remains the same. Do you see this x values? They're going to remain the same, so I'm just going to write those out now. 0, 1, and 2. Okay, the y values though, the y values are going, let's try that again and to do green. The green y values are going to change. Okay, I have to put the original y values into this formula right here. Okay, so let's do that together. Watch. 0. -1 times 0 plus 1. So that's 0, and 0 plus 1 is 1. Okay? And then let's do 1. -1 times 1 is -1, and -1 plus 1 is 0. Okay? And then the last thing we need to do is 8. -1 times 8 is -8, and -8 plus 1 is -7. Okay, let's go ahead and graph these new k of x points. So I have 0, 1, 1, 0, and now 2, -7. Okay, and then I'm going to sketch that in. And what's happening is the points, so this is, the one in black is now my k of x. Okay, what happened to the graph? Let's go through these step by step. So it reflected over the x-axis. Okay, so the green swung over, so this arrow now is down here. And this arrow in quadrant 3 is now in quadrant 2. And then you can see the vertical shift up right there. Okay, so that was question number 2. All right, question number 3. For each function, described by the equations and graph shown, indicate whether the function is even, odd, or neither even nor odd by selecting the appropriate cell. Okay. The first thing I just want to ask is, does it say the word degree? And if you are paying attention, the answer is no. Okay, why is that a big deal? This problem is referring to symmetry. Let's review our symmetry. If it is even, then I have the phrase evenly. So that the graph it's symmetrical about the y-axis. Okay, so they're folded there. That's the taco line, the folding line. Okay, the other one is odd. Also, if you put in negative x, you will get the original function. Now, the other one is odd. Symmetry-wise, this is, you can call this corner to corner, corner. Kind of like an origami. The easiest one you know is x to the first. And when you put in negative x, you're going to get the opposite of the original. And I like to call that op x, or the opposite of x. So negative or opposite of the original. That's how you would do these down here is algebraically. And then everything in orange up here is graphically. So in this problem, you have two that are graphical, so let's go ahead and do this one. Question, for h of x, can I fold that in half in the y-axis? And you can, so that is a even. Okay, can I fold this one down this way? And the answer would be no. Okay, so here's the question. Can you, so it's not even, so let's write that, not even, because you can't fold it on the y-axis, it's not folded evenly. The next thing is, can you do it corner to corner? So let me highlight the corners here. Blue and yellow. Okay, so I like to say that this one, in the blues, there is a mountain and a symmetrical mountain, right? If you rotate it 180 degrees from quadrant 1 to quadrant 3, they're the same. Over here, you have a distant mountain, and you have a distant mountain in the yellow quadrants, or quadrants 2 and 4. So that would be odd. So that graph is k of x. K of x would be a odd. Okay? Just to clarify, that basically just means not even, not odd, or simply no even, no odd, if that makes sense. Let's do let's do f of x. So here I have to do this algebraically. So when you're doing this algebraically, I had that star there, and you need to sub negative x for every x value. So we're going to put in a negative x for every x value. Now, don't worry about the left side of the equation here, okay? Don't forget we're going to use PEMDAS, which tells me I'm going to use the exponents first. So negative x times negative x is x squared, and x squared times 3 is just 3x squared. Okay, so now every time you see f of x, you can write 3x squared. I see 3x squared, I can write f of x. What does this mean? When I substitute in negative x, I actually get the original problem. Another color here, purple. So this matches which description? That would be an even. So f of x is also an even. That substitution, the last part at the end I did, I'm just kind of showing that it's the original problem. That's all. Okay, let's do g of x. G of x equals negative x to the third plus 5. We're going to substitute in negative x for every x value. So I see an x, I'm going to write negative x. It's a way of testing it. That's what it means. All right, so I have g of negative x equals negative. Remember my substitutions there in parentheses to the third power plus 5. Okay, don't forget you're using PEMDAS, so negative x to the third power just means negative x times negative x times negative x. That would be negative x to the third power. And you still have this negative n plus 5. Okay, let's simplify that. So we just tested it by putting in negative x. Opposite of negative x cubed is positive x cubed. Okay, here's a question. Is this the same thing as this one? Are they the same? They look the same. They both have a positive, but this one has a negative and this one does not. So this means it's not even because it's not the original. Okay, how do you know if it is the one where it's the negative of the original? Well, you have to factor out a negative, okay? So what you do is, this would be, you put, well, how do you distribute? So again, think backwards. How can you distribute so they're the same? Well, this would be x cubed, sorry, negative x cubed, right? Because negative times negative is a positive above, and negative 1 times a negative 5, negative times negative gives you a positive. So question, is this the original? They're in red, and it is not. So it is not odd. Okay, so it's not even, not odd. That would give g of x to be neither. Okay, let's go on to question number 4. All right, last question number 4. Which of these graphs represent a function that is neither or not even or not odd? So this is what it's saying, no even, not odd. They're basically saying which of these are neither. Okay, select all that apply. So there might be more, there might be 0, 1, 2, 3, or 4, all of these, okay? So I just copied what I had above, so if it is symmetrical evenly, then it folds on the y-axis there. So this one is not even. How about this one down here? Let's see if I use a highlighter. Is this symmetrical or folded in half so that the left side matches the right side? The answer is no, not even. How about over here? Is this one folded exactly on the y-axis? The answer is no, not even. And how about this one over here? Is this one folded in half so the left side matches right side? The answer is not even. Okay, so I just did the not evens, okay? Let's now do the not odd, okay? And I like to highlight the quadrants so that you can see them. So let me do that really quickly. I'm just highlighting quadrants 1 and 3. And I'm going to go ahead and highlight quadrants 2 and 4. And I'll refer to those as just green and blue. But for your reference, let me go ahead and label those quadrants. So quadrant 1, quadrant 2, 3, and 4, counterclockwise. Okay. Let's do this problem here. Is the blue the same thing as the other blue? The answer is no. You have this tree, and there is no tree over here. So this one is not odd. Okay. Same thing. Is the blue and the blue the same? No, so it's not odd. Okay, getting a little more challenging. In C, is blue and blue the same? No, because you have this tree and this one has a mountain. See that? Not odd. Okay. Is the blue the same? If you rotate it 180 degrees, mountain, mountain, yes. So this one, yes, odd. Okay, so let's look through now and determine which one is not even and not odd. So not even, not odd. So that means that A is neither. Down here, same thing. Not even, not odd. So this is neither. And this one, the last one is a no, because this is not even, but it is an odd. So if you had all three of those, then you got credit. Hopefully those corrections were helpful for you guys.
Math.
Say it again.
Our math.